But thank you, Dayana. Thank you, everyone, for having me here. I'm Masoud Gassari. I'm the Director of Graduate Programs and Research, and also an Associate Professor at the Rinker School of Construction Management at the University of Florida. Before diving into the actual presentation that I have, I want to go and provide a little bit of background that I have. I did my undergraduate in civil engineering, so I'm an engineering. I was an engineering student, like I graduated a long time ago in 2006. After that, I did my master's in construction management. I went to Southeast Asia to do that. A university called University of Technology of Malaysia. That's one of the top engineering school in Malaysia. So I spent 2 beautiful years over there in Malaysia. Then I came to the US to do my PhD in building construction. Then in the US, I was a PhD student for 4 years at Georgia Tech. After that, I worked for a short time in DPR construction. So it's up in their DC area. Because of the top of the research that I was doing, I was leading some initiative about AR integration and also drone integration into their current procedure over there. So then I moved to Mississippi State. I taught there for 2 years in their building science program. And then in 2015, I moved to University of Florida. So I have been here almost a decade, which is a long time. And a little bit about the University of Florida. This is the University of Florida. It's the largest state university in the state of Florida, and also one of the top 10 public schools in the U.S. And I am in the College of Design, Construction, and Planning. So this is the College of Design, Construction, Planning, which includes architecture, urban planning, interior design, construction management. And our building is this one. Dayana has been here. So this is the ME Rinker School of Construction Management, where we offer our own undergraduate and master's and PhD all in construction management. So a few pictures of that. And that's the whole, we have around 30 faculty members and 10 staff, all in construction management. But again, the faculty, they have background in civil engineering, mechanical engineering, electrical engineering, nuclear engineering. But the focus, all of the research and all the education is on the construction management. And we are offering our own undergraduate in construction management, master's, and also PhD, all in construction management. So that was a little bit of where I'm coming from. So I'm also leading a research group called Human-Centered Technology in Construction. And again, as you see in the logo of this, of our lab, there's a human with a VR headset and a crane around it and a drone flying around. So I think this should capture the majority of the work that we do. So all the research that we do is the human is at the center of the research that we do. So all the studies that we do at some level, we are dealing with humans. And there are different type of technologies that we are working with, like drones, VR, AR, and all these technologies need to be polished in order to satisfy the human of the needs of those humans. So this human could be project managers, could be safety engineers, could be workers at the job, but they are at the core of our research. And the top of the research that we do, because it's human-centered, so it goes all the way from the surveys to experimental studies, to interviews, to Delphi studies. So all of them where we get to learn something from the human, which is at the core, but trying to polish the technology to satisfy the needs that they have. So that's the core top of the research that we do. Again, one of the area of research is heavily on the VR, AR, and extended reality. But the topic of my today's presentation is on my other hands of research, where we are doing robotics, small aerial and ground robots that we do for different applications in construction. But the top of the since it's a very wide range of research that we do, I want to specifically focus on drones or aerial robots that we have and how we are using it for the built environment. Like Dayana is as an expert in this domain, and maybe some of you already working with her. So, but like this is the I'm gonna like reflect on some of the studies that we have done, around like 4 or 5 studies that we have done over the last 4 years, way more recent studies that we have done about it. But before doing that, like in 2009, when I was a PhD student at Georgia Tech, like I was doing research on drones. And I remember at the beginning when I was starting, I thought that drone is like a backpack that you can wear, and it can help you to go anywhere you want to go on the job. So that's how I was thinking, like, oh, having drones, it's gonna be like that. And actually, this video is from almost I don't know, 7, 8 years ago, showing a technology called Flyboard Air, which has a which has a flyboard, literally. It's like a jet engine that you can like stand on, and a backpack that can allow you to fly up to 10,000 feet and speed of 93 miles per hour. Hopefully you don't want to do that. But this shows that I wasn't thinking that much outside of the box, and I believe that it should just be a matter of time that we see such technologies even on the construction job side, or like they're already using it as a part in the military, and like some like disaster area, they have already been using this type of technology, but we haven't seen it that much on the construction job side. But that's not the top of the drones that I want to talk about. Like the top of the, I'm here to talk about these type of aerial platform. So this presentation about the common top of the drone, which have been used in the built environment, such as rotary wing. These are very commonly used for vertical top of the construction. We have also fixed wing, looks like an airplane, and commonly used for horizontal type of construction, highways. And I've also seen a few papers or examples of using blimps in both indoor and outdoor type of construction. So these are the typical type of what we call drones or unmanned aerial vehicles or systems that are commonly being used in construction. So again, over the last couple of years, I've been conducting research on the use of drones as safety inspection like the drones are not something new to construction or the built environment. It has, like, over the last 20-30 years, it has been used for a wide range of applications, from structural infrastructure inspection, for transportation, for like cultural heritage conservation, city and urban planning, progress monitoring, post-disaster. So a wide range of application has already there have been already a wide range of applications the drone has been used for. So like, let me give you a few examples of how it has been done. This is actually from almost 12 years ago. I took this video. This is like a drone. It's a fixed airplane, fixed drone, fixed wing drone called EB. And all you do this, you turn on the engine and then you throw it away. And what it does, you already went on the map, and you have captured where you want this to go and fly and do the surveying on. So if you can see here, like this is where, like on the left corner, that's my car, actually, with the other cars that it parked. So in almost 15 minutes, it went and captured 154 images, almost 1 gigabyte of data. and like it was able to create a very, very detailed stitched images that was later on used to create like a 3D point cloud data, which you can use for a wide range of, like for surveying, for cut and fill, for a wide range of application can be used. Like other example, it can be used. I know Dayana used that a lot for like damage inspection, for facade inspection, roof inspection. Like many insurance companies in the U.S., like there are some insurance companies that you have to fly drones in order to go and do the inspection of the roof, or when they want to do claim insurance, running insurance claim or anything like that. So they're very popular for these type of applications. Like again, structural inspection, you can find cracks and do like measurements. Instead of sending humans to the level 20 or 30, you can do more frequent inspection and measurements of cracks and other maintenance purposes can be done, especially for the high-rise building or multi-story type of building. The bridges are very commonly used, especially in the US. This is a very dangerous job for human. Like again, as you see, it's over a river, it could be over a highway. So instead of sending people under the bridge, like drones are heavily being used in order to fly under the drone. Again, there are companies that have developed drones that can fly very close to the steel structures. They can fly in areas that there is no GPS available. They purely rely on computer vision to do navigation and flying. There are companies in the US just doing that. And like Department of Transportation is one of their main customers. Like they heavily use the top of the drones that they have for like their bridge inspection, for their highway inspection purposes. And again, like the newer version of the drone, like they're fully automated, that all you will end up doing is just like you just place the drone on the side. It goes automatically, fly, captures, and comes back and does the analysis for you. This is another the same application of crack detections and measurement, but on the concrete, on the like the concrete dams that has been like done. And again, for road condition assessment, for like using in the pictures on the left, they're using the point cloud to see all the distresses on the highway, and also in the left side, they're using some depth map to reflect the severity of those like road distresses. This is another example for the landslide monitoring and mapping. So they used to do displacement and dynamic modeling. So they run, like they can run it over time, before landslide, after landslide, in order to see how it has been done. Again, I just wanted to show you examples. And again, look at the paper is from 2014, almost a decade ago. So construction is usually behind of most of the like the industry, like unlike like heavy civil that have been using it. Like construction was one of the more recent adopters of this technology, and there was two reasons, at least in the US, that was the main reason of like very common like adoption of the drone technology. Like right now in the US, agriculture and construction industry, these two are the top two users of drone technology on the construction jobs. And most of the construction job site that you go, they are heavily using drones. And the main two reasons are like the technology good, super cheap and easy to use. Like originally when I was like in 10, 12 years ago, a good quality drone, when you wanted to purchase, it was 20, 25K. Right now with $500 to $1,000, you can get a pretty reasonable quality drone that can do the majority of the work that you need. And also, it has been very easier to use, and that's because of also the regulation around use of drones. A couple of years ago, Federal Aviation Administration of the U.S., they made the use more easier. Then we saw a surge in the use of drone in the built environment as well. And also many companies have started just creating user interfaces, softwares, hardware, just to satisfy the needs that are in the construction. Again, as I told you, they are getting so easy that you can just have a drone itself. You can take it to the site. You can place it on the job site. It does the fully autonomous flight, goes, captures it. All you need to do is that the drone comes back. You swap the batteries and add the new batteries, and it goes and captures and comes back. And again, nowadays there are boxes coming up where the drone is just lands in the box, gets charged, and go fly again. So technically no human involvement in the process, and it lands, has the data with it, pushes into the cloud, and you can see in the cloud the data that you need for if you're doing progress monitoring, if you're doing facade inspection, roof inspection. All those data is already available, and you can have those data captured more frequently, every day, every week, as needed based on the type of the task that you do. So that was to provide you an overview of where we are in the adoption of this technology. My part and the top of the research that I'm doing is on the construction safety. We have heavily used the drones for construction safety purposes. And again, over the next few slides, I want to show you that how we have done it. So the type of the research that we do for drones and safety, I want to break it down into two specific categories. One, drone for safety, or how we can enhance the safety on the job site using drones. And two, safety for drones, or how we can ensure the safe integration of such flying robots on the construction job site. Because the job site is already dangerous work environment. Now you're introducing a robot that's gonna fly on top of people's head. People gonna get distracted. It's gonna fall down. So all of that are introducing other layers of unsafe situation to the workers on the site. So we need to study both how this technology might be used for safety and how we can make sure it's safely integrated on the job site. So using drone for safety purposes on the job site, I want to show you a few examples how we did it. Again, this is a high-rise. In this specific study, we used drones for the safety inspection of multiple high-rise building projects. We investigated the practical benefit and challenges of drones for the safety inspection on these job sites using various data generated by drones, and studied how safety managers could integrate such technology and their generated data into their day-to-day safety planning and monitoring process, and finally proposed a process map for this successful integration. So why drone can provide, again, the whole idea is that the drone can provide another eye on the job site. These multiple high-rise building projects, it had one safety manager who might have been able to walk on the site once a week to capture different things because they were in charge of different projects. So the whole idea is that how such technology can provide more frequent inspection, more frequent monitoring on the job site to make sure that we are not putting people in danger on those job sites, or if they're in danger, we can save the lives earlier. And again, just a few examples, how we assess different type of drone-generated visual data, such as images, videos, point cloud, to see how useful they are for hazard identification purposes or other type of safety planning on the job site. The main challenge in this study was that we were bombarding the one or two safety managers who were on the project with substantial volume of data, including videos, images, and point cloud. They were telling, okay, on top of what you were doing, now look at these 1,000 images and videos and point cloud that we created to inspect the safety on the job site. We were expecting that we have multiple drones flying on the job site, capturing a lot of data for you, safety manager, to do your job better. So in addition to everything you were doing, just take a look at all of them and make decisions. So again, it sounded an interesting idea, but you can see how crazy our expectation was from the safety manager. So this brought us to another study focusing on how we can better and quickly make decisions from the large amount of data that such robot can capture on the job site. So instead of like expecting the safety manager to make a decision and looking at all of that, so we can automate the process. We can do some automation, and then a report or something can be provided to them so they can go ahead and check it out. This specific case study focused in a high-rise construction project where we employed drones to assist the limited number of the safety manager on site, enhancing the frequency of their inspection. So that we wanted them to do more frequent field trip. And instead of like safety managers walking multiple stories every day to check various safety features like safety nets, guardrails. So the drones were providing them with additional eye on the job site. So that was the first part. But we also developed a machine learning system that what it was doing, like it was this AI system was developed to detect guardrails. Like one side of it was the guardrails by the drone, and provide a report for safety managers. It was categorizing them and making sure like all the guardrails have been properly installed. If there was a missing guardrail, so the visual was marked and it could say level 3 this side. So that way the safety manager, instead of looking at hundreds of images, okay, this is the issue, go and check it out. Hopefully it's not just a issue with the framework that developed, because there was an error tied to it, but we got it to 90-something% accuracy rate. So, but the whole idea, the outcome of the research illustrated that if we have automated AI-oriented system, they could improve the recognition of guardrails or even other things, safety nets, hard hats, and other things. And this could facilitate the safety manager's task of identifying fall hazard, for example, in this case, in high-rise construction project. So them looking at thousands of images, we provide a report or something or notification system that, okay, these are the parts that are missing a guardrail. These are the parts that are missing a safety net. So they can go and check it out and make sure that it has been addressed fast. So in addition to focusing only on the data collection by the drones, we also explored the hardware aspect of it. This was the hardest part, that we said, let's us customize such platform to meet the safety needs that we have on the construction job site. Because most of the drones that we have been using are off the shelf one. We bought it and said, okay, let's use it and see what type of sensors it has, what type of characteristics it has to use it. But the reality is that construction sites with almost 1,000 fatalities per year only in the US are one of the most dangerous ones. And we need to, we are introducing this robot that, in our case, aerial robot that would fly on top of their head. This would lead to a more hazardous work environment. So the idea was to consider changes that we can do in the hardware or the way that these hardware can work to make the flight of the drone safer on the job site. Said, okay, we're going to fly it, but how it could be safer. So we did it in this study, in this specific study, we introduced and assessed a drone called iSafe UAS, which is the first drone platform designed specifically for safety inspection purposes. And the two capabilities that it had, it helped us to achieve that. One was the parachute recovery system to make sure if the drone flies, it's not going to kill people this heavy drone when it flies. And the other one was the super optical zoom capabilities that it has. So instead of flying very close to the building on top of the people's head, we can fly further away. So let me show you how these two aspects work. Again, For the parachute recovery system, the results showed that these just having a parachute to the drone could reduce the fatality probability by more than 40%, which is very significant on the job site, especially if you're dealing on a super crowded job site that you want to fly drones on top of that. The other aspect, again, like I'm just showing you a few pictures here or there. At this particular job site where we tested the iSafe UAS, we were flying 130 feet away from the building. So even like there was no, the workers couldn't even see the drones, they couldn't hear the drones, so we were far away. So we were flying on a safe area far away from the building. Although we were at considerable distance, as you can see in all these pictures, because of these super zoom capabilities that we had in the drone, we were able to inspect a significant number of potential safety hazards without actually the need to fly over workers or even get close to the building or cranes. It had crane, like I think it had 2 cranes on the site, job site. So we were on a site way further away from the building, and we could get look at that, like we could see improper installation of the guardrails or some improper indoor housekeeping, like the improper warning signs around the electrical panel. So we could see all of that without the need of flying on the job site or close to the building. So now that you got an idea like how drones through different sensors that it has, like images, videos, and like point clouds that can be generated from the drones can help to do safety inspection, I want to like take you to another series of project, which again, like it's safety for drone. And until now, our focus has primarily revolved around the robot. So we didn't care about humans that much. However, the complexity significantly increased when we introduced the human element into this equation. So in this part of the presentation, we will delve into the various complex factors that arise when humans interact with these robotic technologies and some of the studies that we have done in this area. So hopefully, okay. So again, like this is a slide I created to show how introducing a robotic element, in this case, an aerial robotic element, can make if you are also looking at the human, that the human is at the core of our study, how it has impact on many sides of the work that we do, all the way from the worker well-being to the trust that the workers that they may have around the drone, and also the work safety might impact it. So I can't tell you on how many projects when we were flying the drones, almost all of them, some of the workers came in and, what are you doing? Are you like recording us? Are you checking our productivity? Am I in trouble? How are you using these videos? Like many questions. So again, like as you can see, first, like we are introducing a robot which might put them in danger, like the work safety. So it could be unintended contact, like the workers might be distracted, like they might get like this, like they might get stressed, the cognitive load of interaction might increase. There are trust issues that, okay, like how this drone's gonna help me? Is it helping me to be safer on the job site, or is it gonna check my progress, and if I don't work well, I might be fired from the job site? So they don't trust these robotic elements. They don't look at them as the co-workers, that they're there to work with them. So like the whole driven by the how those aspects could be studied. You can see how complex it gets, and also the worker well-being. Also, not only the stress, but also it might have physiological stress on them. They might have like their well-being might be impacted just by introducing those robotic elements. Like, are they going to replace me? Are they going to monitor me? Are they a big brother checking me out? So you see like a lot of elements going to play into a role when we are dealing with such robots. So we were lucky. We got like close to a $1 million project from the U.S. National Science Foundation to study this issue and the complexities around how introducing aerial robotic elements on a construction site might impact all these, from the safety to trust to the worker well-being, all of that, and how we can make this how we can make this situation better. Okay, so now let me show you a few studies that we have done in this area, like to cover this aspect. So like the very first study that we did in this area was about the impact of drone presence and construction individuals working at height. Okay, so how drone impact workers on height. Why workers at height? Because why workers at height? Because they are the most vulnerable population in the construction. Most fatalities in constructions are due to falling from heights, and coincidentally, drones also fly on height, thereby like they're having the most influence on the workers that are working at height. So what we did, we created real-world VR scenarios that showed like different working conditions, working on roof, working on ladders, working on scaffolding. These are the top of the scenarios that, looking at the U.S. Department of Labor reports, the highest number of the fatalities happening in these type of height, line, the roof, on the ladders, and like scaffolding. So we created scenarios in VR because we were not able to do it in real world. It was unsafe, and we were creating unsafe scenarios, and we couldn't even get the approval, and also we couldn't do the job. So that's why we did like the studies in the VR. Like this is an example that like if you can look at the VR scenario, that the subjects were on the like a second step on the ladder, but in the VR they were on the like a high level of the ladder. And another one, they were working on here, but actually they were on the roof on the job site, but they couldn't, like they were fully immersed in that virtual environment. Or also they were on the roof and scaffold. Sorry, the second one scaffold, the third one was the roof. As you could see, is steeped in a little bit. And we did in this scenario, we did with drone presence and without drone presence, and we collected a wide range of data from the heart rate to precipitation, like a wide range of physiological and emotional data. But again, and the result have been published in this journal paper at ASC, Journal of Construction Engineering and Management. But I wanted to share two interesting results from this study. So it showed that the drone presence was not associated necessarily with changes participant physiological and emotional state, but they were diverting their attention from the sign task. Like when they were working on the roof, when the drone was present, they were keep looking at the drone. So there was clearly distraction happening. So that's something we learned as we were we were looking at the eye tracking data of the system, that like significant amount of the time, all the workers who were in this scenario while they were working at height, who as soon as the drone was present in the conditions, they were keep looking at it for a good amount of time. So that's interesting. So the next study evaluated the actual physical risk that drones that we had. Like in this study, again, unlike the previous one, we noticed that, okay, like they're looking at it and they might have like physical risk of drone like hitting the workers or anything like that. It's falling on the roof or anything like that. So what we did, we used the 4D simulation so we can test many parameters. So what are the possible situations? We created a dynamic simulation of the construction scenarios with different type of the drones performing their tasks and equipment and virtuals and other equipment. So we ran it for like thousands of times. So again, like we changed the flight speed, we changed different like parameter, like simulation parameter, and we measured a lot of different type of the collisions, like drone to building, drone with worker, drone to equipment, drone to other drone, drone to the ground, like it fell down. And some interesting result that I want to share with you is that the distant drone, the drones that they were further away, a higher frequency of collision they had, because like again, there were more movement in terms of the crane. So those type of the near drones had a higher frequency of collision with buildings and the workers. So these are the two interesting observation that we had. So based on that, so we learned that drones at different distances, if they're near or if they're close, they might have different impacts in terms of the collision and ultimately the workers that they're working with it. So we said, let's look at the distance then. Let's look at like how drones presence. So we already looked at the presence, but in addition to that, how drones presence and distance gonna have any psychophysiological impact on the workers. So we used like a very common like a psychological distance, the Hall's psychological proxemics distance, which categorize the distance and the spaces into four categories of intimate, personal, social, and public. So this categorization is very common in the human-robot interaction. So we used it for the drones. We wanted to see, okay, like when the drone is at these 3-4 different stages, when they're in the public space means like they're further away, over 12 feet. When they're closer all the way to very intimate, when they want to get close. And again, in construction, we might have scenarios like the drones might deliver something to you. So the drone might get very close to you, or you might touch the drone, interact with the drone for different purposes. So we wanted to see how these humans, different psychophysiological might have different psychophysiological impact in different distances. Again, so like in this experiment, we created again another VR experiment with 4 conditions where drones were in 1.5 feet, 4 feet, 12 feet, and 25 feet, like very like similar to the 4 areas in the Hall's proxemics distance that I just showed you in the previous graph. And like again, 2 interesting observation that we learned from this is that the drone presence for sure had some physiological impact, caused distraction, and reduced construction professional attention to the task that they had. Like in all of them, we could see that. But one thing we interestingly noticed in this study, that the drones that they were at some distance, like they were like 25 or like further away, they caused more distraction to the workers than the drones that they were closer to them. So like, again, we were thinking completely the opposite. We were thinking, so if the drone gets closer to the human, like they get more distracted, but the drones that were further away, like apparently was were making more distraction, causing more distraction based on the looking at the eye tracking data that we had. So while this may seem like counterintuitive, it's actually in line with other human-robot interaction. Like although annoying at closer distances, the drone was trusted more and accepted faster by participants as they could know the drone's intention and clearly understand its role and like what it does, what it would be in future movement going to be. It's going to going that way, that direction. On the other hand, the drones that are at distance may be assumed to have a surveillance role, like the big brother role, which could provoke like higher distraction. Like also in addition, being at distance, drone can provoke like curiosity to observe and have a clearer understanding of what drones are doing and what their flight intention are. So they would keep looking at what the drone is doing. Is it getting closer to me? Is it flying away? So that's an interesting observation that we could like see it in the eye tracking data that we collected from this study. So in all of this study, as you notice, like the human is flying passively, workers working passively. So there's no communication interaction between them. So the worker has nothing to say to the drone, and the drone cannot do anything to the workers. So they cannot talk to each other, communicate to each other, anything. So our next idea was that, okay, so what if we can provide some way of like a communication between the humans and the drones? In our case, was the whole for safety purposes. That okay, like if I'm a worker at height and I get distracted by a drone, or I get uncomfortable by a drone looking at me, I can just simply tell the drone, go away, or don't do that, stop. So right now, again, it's not going to happen because most of the drones are just having either fully autonomous drones or the drones flying by the pilot. So the workers on the site who might be in danger because of the drone presence they don't have anything to do with that. So, but again, there is a lot of push into that, make the people create like a two-way communication between these robotic elements and then the humans. So that's why, at least in terms of the workers who are working on the drone, can provide some safety intent and safety concerns with the humans if they face such situations. So in this case, in this scenario, we were trying to create some gesture and speech communication, like we were relying on gesture and speech communication modalities to see how giving this power to the workers, just the typical workers on the job site, how that can make them feel better, and what type of, and with feeling better, what I mean is that what type of psychophysiological impact might have on the workers. Okay, so we used some of the literature on dog training and animal training, and we used some of those gestures and speech, very simple one, to see how giving this power to the workers on the site, in the future of construction sites where there are a lot of robotic element flying, how these communication can enable them to feel safer. So like we integrated some speech and gesture like stop, back, go away, and keep going. Like you can go, you're safe, you can go and continue whatever you are doing that. So we just gave this power and we ran the same thing, like heart rate, like stress, eye tracking data we collected. And we noticed, especially in terms of the gesture, giving that power to the workers can help mitigating the physical risk without imposing like any cognitive strain. So when the workers felt empowered, so it mitigated the physical risk that the drones might have had on the job site, which is an interesting observation. But one thing to remember, like in all these experiments that we have done, like it was a one-way communication. So right now, only the human can talk to the drone. So it didn't know whether the drone, like what is the intent of the drone, what the drone is doing, like whether it got the command that it provided to drone. So in our other set of study, we looked at other studies that have been done heavily used in air, like the robotics, and we tried to make this communication two-way. That okay, I might use some gesture, I might use some speech to provide certain type of the comments, all the safety related comments when I feel unsafe to the robot, but how can the robot can talk back, or I can learn more about what are the intents and safety intents of the mission that the robot has. Like in this case, we used light and sound of the robot. Like for example, if the drone was getting close, so the light and sound, like it was blinking and like it was providing a signal to the workers. When it was wanted to land all the time, it was doing a spiral. When it was spiral, so all the workers knew that it's going to land somewhere around that area. When there was a communication between the human robot, if the robot captured what it meant, it was nodding like a human, okay? But the nodding was the robot was doing this. And if the robot is thinking or or you have said stop to it, so it does 8-figure flight path. So again, like most of this is very like we used most of the literature in the robotic, which they have been using similar type of the flight path signals and lights in order to create the robot to human type of communication. And we just adopted and make it more for the safety intent purposes, like that the robot is approaching, the robot is landing, the robot is confirming what you meant, the robot is pending and deciding whether it should continue the mission or stop because you said stop before continuing the mission that you provided. And again, these bidirectional human-drone communication significantly reduce the physical risk, reduce the stress level, and reduce the negative attitude that they had toward the drone. Again, we did with communication, without communication, within subject experiment, and like we noticed, like when you give that power, that capability to the humans, they feel less stress. They feel they have less negative attitude to the robot because they know, okay, so I know it's not a big brother. I can have, like, if I'm not happy with something, I can stop it. I can say, go away, or I can make that the drone at least doesn't fly close to me. All these capabilities make it made it better. So all of that capability also, like in this scenario, showed us it can enhance the perceived safety of the workers. And also we quantified the number of the time they were using gesture, they were using speech, and also most of gesture was pretty common. And most of the time, even though they were using gesture, they would say, stop. They would say, go away. So instead of just saying go away, they were using both like a mode of gesture plus speech together. And again, this is a study that was just accepted in the ASC Journal of Construction Engineering and Management, and hopefully it will be available online very soon. But again, everything that we did so far was in with virtual drones. And again, you can understand why we did that, because all the scenarios that we were creating was very unsafe. The humans had to get very close to the robots, and getting approval for that was super hard. But like toward the end of these phase of studies, like which is actually the study that we just did this year, we tried to create a very simplified version of the same study that you saw in the VR in the real world, to see whether we did everything in the VR, but really whether all these communication modalities, whether providing the same capabilities can translate in real world and in the real world scenario. So again, this is an ongoing, we are currently doing, we collected the data, we are doing finalizing the data analysis and the write-up, but a similar scenario was created. Again, as you could see, the drones were following the same gesture, like nodding, going away, spiral, landing, and all of that, but within a real world drone with a real human on the real simulated site. For example, like we couldn't do it still in the kind of controlled environment. We couldn't do it in the construction site. We have to control for weather, for many of these factors to be a true experiments. But it was a real scenario with real drones on a real controlled lab kind of construction simulated site. But again, we got very similar. Again, we are not done with the analysis and the write-up, but very similar results that we got in the virtual reality. Also, we got it here, that giving this power significantly reduces the stress, significantly increase the perceived safety that they have. And also the gesture was a very, very the popular modality that they used with the the tasks that they were doing. So again, the drones are not just a part of the research that we do. We use it in the classrooms. I'm teaching courses on the technology integration construction, where we do hands-on drone use in the construction job site. This is the classroom. The bottom one is some activities that the students are doing for building inspection type of activities. We also, the similar type of the virtual environment that we create for where we have drones present on the job site. We also use them for the training purposes. This is an example that we are using in the classroom to show how we can fly drone for doing some kind of inspection in the classroom. We also have done some project for U.S. Department of Labor. Again, they are in charge of OSHA or safety training on the job site. So we have created some, using the same virtual environment that we have. We created trainings that you can go and provide, which discuss a different safety aspect on the drone integration on the construction job site. And we also, in addition to the drones, and in addition to top of the research that we do, we are exploring speech, gesture, touch, other communication modalities. We are also using other top of the robots, like four-legged robots. We are also using Husky, like a ground-wheeled robots. We are integrating AI capabilities to it for safety monitoring on the job site. We are adding human-robot interaction aspect to it, where there is the iPad with a human face on it, so you can interact and instead of robotic presence, be like a robotic, we give them some human characteristics, so that way the workers can interact and can talk and communicate with them on the job site. So I just wanted to give you an overview of other top of the robotic related studies, but at the core of all of them is the safety as well. And I couldn't have done any of this research without amazing work of our PhD students, and also our previous PhD students who are now, all of them are assistant professors at some of the top universities in the US. And for sure, all these projects have been funded by different funding agencies in the US, like National Science Foundation, the Center for Construction Research and Training, US Department of Labor, National Center for Construction Education and Research, Electra International, and our last project, which we are using, we are doing similar studies, but on the fatigue, the robotic presence on the fatigue, which has been funded by McElhatton Foundation.